11.5, 2 more sections to go for new material, and then final review and final. Okay, any work you have, get it in, even if it's missing. Anything from chapter 7 on, I will take. So get it turned in, okay, as quick as possible on Google Classroom, please. Easiest way for me to grade it for you guys. Okay, all right. Circles and their area and sectors, okay? So, you've seen how to find the area of a polygon, right? You have to divide it up into triangles, find the length of the apothem, the length of the side of a regular polygon, and then you can find its area, okay? So you can see that if you have a polygon that's inscribed in a circle, as the number of sides of that polygon increases, the polygon gets closer and closer to being just the full circle, okay? So that tells us that the area of a circle, in theorem 11.7, is just going to be pi times the radius squared. Generally, I will prefer your answers left in terms of pi, right? So for example, if you have a radius that's 3, then the area is going to be 3 squared times pi. So I would like to see it as 9 pi square units. Okay, I don't necessarily want you to multiply it out, okay? If you're looking at the book, they probably do, and they will use 3.14 for pi. This is just going to give you an approximate answer. It's not going to give you an exact answer, okay? That's why for me, I like it in terms of pi. Okay, so to find the area of a circle, just take the radius and square it, and then multiply it by pi. Okay, so radius is going to be 3 meters. Okay, then the area is pi times 3 squared. 3 squared is 9. So we get 9 pi square meters. If you're looking for a decimal approximation, you would get 28.3 meters squared. Okay, so it's just a matter of taking that radius, squaring it, multiplying by 3.14, and that tells you the area of that circle. Okay, if I have a circle that has a diameter of 18 feet, I want to find its area. Okay, but area says you need to know your radius. So we know that the diameter is twice the radius. So the radius is going to be the diameter divided by 2. So in this case, our radius is 9 feet. So then the area is pi times 9 squared. 9 squared is 81. So our area would be 81 pi. If you want a decimal for that, it's going to be about 254.3 square feet. Okay? So you just need the radius and you can find the area. Remember that diameter is twice the radius. Okay? All right. Then we have sectors. So a sector is like a piece of the circle. Okay, so if you think of like a pie, right? Here's your whole pie. When you take a piece, you're taking a sector. Okay, so this would be a sector. By definition, we say a sector of a circle is a region that's bound. So it's closed in by 2 radii. So this is my sector. This would be a radius and this would be a radius. This is your center. Okay? And they're intercepted arc. So this is P, this is arc AB. So we have sector APB is bound by the two radii, so AP and BP, and arc AB. Okay? So then, just like circumference and arc length were related, area of a circle and area of a sector are related to each other. So that's what theorem 11.8 tells us. It says that the ratio of the area, so we have ratio of the area of a sector to the area of a circle is equal to the measure of the intercepted arc over 360. Okay, so if we call A the area of the sector, A over area of a circle is pi times the radius squared equals the measure of the arc compared to 360. Okay, you could get A by itself if you wanted to, right? Just multiply by pi r squared. So A equals the measure of the arc over 360 times pi r squared is what the theorem tells us. So it tells us how to find how much pi we're getting from the circle. Okay? All right. So example problems. Okay. Here is a circle. The center is at X, and we have this sector here. The radius is 11 meters. The measure of the central angle. So this is what we're going to have filled in. Okay, this is Y and Z. So you're told that the radius is 11 meters. The measure of angle YXZ is 135 degrees. You want to find the area of the sector. Okay, so theorem 11.8 tells us that the area of the sector is equal to the measure of the intercepted arc over 360 times the area of the circle, so pi times the radius squared. Okay, so the measure of the intercepted arc is going to be the same as the measure of the central angle. So the intercepted arc is 135 degrees. And then the radius is 11 meters. Okay, so plugging that in, we would get 121 times 135 over 360 times pi. And as a decimal, that is about 142.5 meters squared. Okay, if we're using pi, it's going to be 45.375 times pi. So that fraction doesn't simplify completely, okay? So that's why I tended to use a decimal for that one, because you're gonna get a decimal no matter what, okay? So radius squared, and then the central angle and the intercepted arc have the same measure, and then just plug them in to get the area of the sector. Okay, so I have a triangle inscribed in a circle. So here is my circle, here is a triangle inscribed in it. Okay, it is an equiangular, equilateral triangle. Okay, and then we want to find the area of this shaded region. okay? You are also told that this is a right angle and this is 4 centimeters. So your center is here. Okay? So to find the area of the shaded region, it's going to equal the area of the circle minus the area of the triangle, okay? Because it's a circle and then the triangle is not shaded. Okay, so the area we want is the shaded part. So the area of a circle is pi times the radius squared. The area of an equilateral triangle, which is what this is, because you have the marks to show us all sides are the same, is going to be 1/4 times the square root of 3 times a side squared. Okay? All right, so then we can start with what we know. We know the radius, because if this is our center, the radius goes from the center to a point on the circle. So the radius is 4 centimeters. Minus square root of 3 over 4 times a side of the triangle squared. We don't know the side of a triangle right off the top of our head, okay? Because we just know the radius. But we can look at that triangle and say, okay, it's a right triangle. This side is half the side of our triangle. So this is our side of our triangle divided by 2. We know this is the hypotenuse and it's 4 centimeters. Because this was an equilateral triangle, we know this angle is 30 degrees. So we want to find the side next to it. So the cosine of 30 is the side adjacent over the hypotenuse. So, okay. Then we want to get the side over 2, so we're going to multiply s over 2 equals 4 times the cosine of 30. And then to get the full side of the triangle, we're going to multiply that by 2. So 2 times 4 times the cosine of 30. And this, when you plug it in, is 6.9. So the side of your triangle is 6.9. Goes here. So the area of the shaded region is going to be, this is 16 pi minus 6.9 squared divided by 4 is 12 times the square root of 3. And then using a calculator, you get 29.5 centimeters squared for the area of the shaded region. Okay? All right, one more. So we had to use the triangle, what we know about triangles and trig ratios, to get the measurements for area. Okay? All right, last one for this section. So again, you have a circle. You have a sector taken out, kind of looks like Pac-Man, okay? Hopefully you know what that is. So that's our center, okay? And this is point A, point B, and we're going to call this point G, okay? And then this is all shaded in. And we're going to use information about this to find the diameter of the circle. And then this arc is 72 degrees. And the area of the shaded region is 277 meters squared. Okay? So what we do know is that the area of the shaded is going to be the area of the circle minus the area of the sector. Okay, so the area of the shaded we said was 277. The area of the circle is pi times the radius squared. And the area of the sector is going to be, actually we don't need this. You can do it that way, but then you have to find the area of the sector by itself. So we're going to use the sector to get it by itself. Okay. So we have two pieces of the circle here. The shaded versus the unshaded. Okay. So the shaded part is also a sector. So we're going to say the area of the shaded over the area of the circle is equal to the measure of the arc divided by 360. Okay, well the shaded part we know. So we know 277 over pi r squared equals the arc. Well, this arc is 72. So the big arc that we want is going to be 360 minus 72, which is 288. Okay, then we're going to solve for r, because once you get r by itself, then you can get the diameter. Okay, so cross multiply. 288 pi times the radius squared equals 277 times 360. Then r squared is going to be 277 times 360 divided by 288 pi. And then take the square root of that. So r is the square root of 110.3. which is 10.5. Okay, then the diameter is twice that. So diameter is twice the radius. So the diameter is 21 meters. Okay, we're just using the area of the sector to get information about our circle. Okay, all right, area of sectors in relationship to the area of a triangle.